All right, welcome back. Chapter 26A. This is the beginning of Chapter 2B. It's the second half of Chapter 2. All right, proving angle relationships. We just proved some segments, congruent and segment relationships. All right, so we previously have identified new special pairs of angles. They're going to be coming up again here. You'll see we have supplementary and complementary. And we have right angles. Congruent is not a type of angle, but it just says that two angles are the same measure. Vocab, this really is a review. Supplementary, two angles that add up to 180. Complementary, angles add up to 90. Linear pair, a pair of adjacent angles with non-common sides that form a line. Linear pairs are supplementary, very important set of angles, linear pair. Vertical angles, we've done them, formed by intersecting lines. Okay, protractor postulate, much like the ruler postulate. Again, I would say over the past 5 years or so I've been teaching geometry. I don't think I've ever used it, but basically it says that if you have one side of your angle at 0, which is here, that when you measure that angle, it's going to be positive. We never measure in negative units, always positive units. Okay, we had the segment addition postulate. Now we have the angle addition postulate. If we have adjacent angles, and this point is in between or between rays BA and BC, then these two angles, marked X and Y, add up to the whole angle ABC. And they have it right here. They have, I'm going to just go to letters, angle X plus angle Y, and they're trying to get these out of the middle here. There's Y. Trying to keep my colors. There's X. And then that equals this right here, angle X plus angle Y, whatever that happens to be. Okay, so the whole angle equals the sum of the two smaller angles, provided they are adjacent. Okay, using a protractor, construction worker measures that an angle a beam makes with the ceiling is 42 degrees. What is the measure of the angle the beam makes with the wall? Okay, so the ceiling and the wall together make a 90-degree angle, of course. Oops, I don't have my straight line drawer thing on, so is what it is. There we go. Right angle, of course, 90 degrees. All right, we have some beam, for whatever reason, going like this and forming a, what's it tell me here, a 42 degree angle. They're asking for the measure of this angle right here. So they have a setup. We could call this angle 1, angle 1 here. We could call this angle 2 here if you want. That fits in with the notation they have up above. Angle 1 and angle 2 add up to 90 degrees because it's a right angle. Angle 1 is 42, so we stick it in there by substitution. Subtraction property, both sides minus the 42, ending up with angle 2 equals 48. I would probably call this simplify if I were going to do the proof here. That's what we did. We simplified. We did 90 minus 42. We did 42 minus 42. That's combining like terms. That's simplifying. So angle 2 is 48. All right. If the measure, okay, we have adjacent angles. They share a side. Okay, the side they share is this K whatever. There's no letter out here. But that ray is shared. So we know right now angle 1, measure of angle 1, plus the measure of angle 2 equals the measure of angle JKL, using the letters there. All right. If the measure of angle 1, find the measure of angle 1, so we're finding this one. If the measure of angle 2 is 58, and the measure of angle JKL is 162. So from here all the way around to here is 116. 1/6. Get your hand off the screen. What's going on? Oh no, don't freeze up on me. Whew. Okay, 162. All right, so we're just going to plug into our equation. Angle 1 we're trying to find. Trying to find measure of angle 1. Plus measure of angle 2 is 58. Equals 162. That's the measure of angle JKL, 162. So we're going to minus 58. Minus 58. Again, we turned geometry problem into an algebra problem. Once we got to here, it became algebra. Up above that was geometry. Measure angle 1 is, oh boy, 162 minus 58, might be 106. Getting calculator out. 162, don't want to mess it up if I don't have to. Minus 58 equals 104. 104, there it is, 104. By the way, make sure when you're doing your notes, I really don't care what the answer is per se. This work is what I need to be seeing. Supplement theorem. If two angles form a linear pair, then they are supplementary. Okay, this is a linear pair, the classic linear pair setup. We have two angles. They're non-common sides, which is this one and this one. Their non-common sides form a line. Okay. And also says they're supplementary because we know through past experience that a line has 180 degrees. Non-common side forms a line means they're supplementary. Okay, the complement theorem, non-common sides of two adjacent angles have to be adjacent, of course, same up above, form a right angle, then the angles are complementary. Well, of course. So if these rays here form a right angle here, I don't know how, ooh, that's a pretty purple here, then these are complementary angles. Okay, complementary, 90 degrees, maybe I'll throw it 90 in here, 90 degrees in there. Okay, angle 1 and angle 2 add up to 90. Complementary. The 4 o'clock, at 4 o'clock, the angle between the hour and minute hands is 120. Okay, so they're telling us right here is 120 from there to there, there to there. Bam. The whole thing, 120. It's great about the color coding. It keeps things a little straighter. Easier to see and handle. When the second hand bisects the angle between the hour and minute hands, what's the measure of the angles in between? Bisects. Bisects makes two. Bisects two equal parts. Okay, so in here. Oops. In here. This is the second hand. It bisects that angle. Means this angle here and this angle here are the same. They are equal. So if you have 120 total, you take half of 120 and you get 60. So each of these angles is 60 degrees. We just did that. This diagram shows one square for a particular quilt pattern. If the measure of angle BAC, notice I go right to my picture, start marking what I have, is the same as, it will be there if I go backwards, BAC, hopefully I didn't mess up the previous page when I went backwards. Nope, yep, I did right there. Boom. 60, get that back in there. Angle DAE equals DAE, so we'll do same color. They're the same. They did same color too. They have kind of that yellowish gold color. So these are each 20s. 20s. And, okay, we got something new. BAE is a right angle. BAE is a right angle. Find measure of angle CAD. Okay, this is what we got going on. We have angle BAC plus angle DAE. We know those are both 20. Plus that green angle in the middle, CAD, equals 90 degrees because it's a right angle. These are each 20s. This one we don't know. But that's no problem for us because it's an algebra problem. So we're going to subtract 40, both sides. Angle CAD is 50 degrees. Bam. Okay, find each measure. Find the measure of each numbered angle and name the theorems that justify your work. All right, so angle 2 is 26. Angle 2 is 26. Angle 3 is what we need to find. Well, if we're a right angle on the left side, we are a right angle on the right side. So we have a 90 degree total in here. So angle 2 plus angle 3 equals 90. And that'll be true all the way through in case this comes up again. Angle 2 is 26. So we're going to minus 26. Angle 3 is 90 minus 26, 64 degrees. All right. Next picture, angle 2 and angle 3 again. We just did that. Angle 2 and angle 3 equals 90 degrees. So that's number 1. Number 2, angle 2 plus angle 3 equals 90. I don't care what they are. We'll just throw them in here. Angle 2 is x. Angle 3 is x minus 16 equals 90. It's no biggie for us. 2x minus 16 equals 90. X plus x is 2x. We're going to add 16 to both sides. 2x equals, was that 106? And divide by 2. X is 53. Okay, they want us to find the angle measures. So angle 2 is x, so angle 2 is 53. And then angle 3 is 53 minus 16. Just substituting in up there. 53 minus 16 is 37. 37. So angle 2, angle 3. Alrighty, 4 and 5. We'll just do number 3 and then we'll move on. We'll get a new color here. Angles 4 and 5. All right, angles 4 and 5 form a linear pair. Non-common side forms a line. They are adjacent. Okay, now just on a side note, 4 and this angle down here are vertical angles. We know that they're congruent. We had that a long time ago. 5 and this angle here are vertical angles. They are congruent. We've had that a long time ago as well. So that is old news there. But here we have 4 and 5 make a linear pair. Okay, we'll go over here, which means, this is problem 3, angle 4 plus angle 5 equals 180. And that's true for all problems through here with this picture. Angle 4 is 2x. Just looking back here, problem number 3. Angle 5 is x plus 9 equals 180. Combine like terms. Minus 9. Divide 3. 3x equals 171. 171. Does that divide by 3? It does. 57. X equals 57. Okay, angle 4 is 2x. So that's 2 times 57, which I think is 57, 10, 114, 7 is 14. And then angle 5 is What's angle 5? X plus 9. X plus 9, which is 57 plus 9. 9 and 7 is 16. 66, isn't it? 114 and 66. All right, so number 4 is done exactly the same way. Refer to the diagram of the parking lot. Given 2 and 6 are congruent, prove that angle 4 and angle 8 are congruent. Okay, so we're going to start with, where am I going here? I'm going to start with the given statements, reasons. This is number 5. Okay, what is given? Angle 2, congruent, angle 6, angle 4, congruent, angle 8, and given angle 2, or number 2, it's angle 2, number 2. All right, so here's our picture. Angle 2 and angle 6 are the same. There's angle 2. I may have made that a little bit too long. Let's back up a little bit. Angle 2 is here. Angle 6 is here. They're the same. All right. Also, angle 4, which is here, and angle 8 are the same. And, or proving 4 and 8 are the same. Oh, 2 is congruent to 6, 4 is congruent to 8. Gotcha. Okay, we're going to prove 4 and 8. Time out over here, then. Let's get this out of here. Scissors that thing. That's going last. That's what we're trying to prove. Let's get this thing down here somewhere. Boom. We can take this and move it up here. Step number 2. Step number 2. Figures. All right. So 2 is congruent to 6. We know that angle 2 plus angle 4 equals 180 degrees. Angle 6 plus angle 8 equals 180 degrees. That is the supplements theorem. They're adjacent. Non-common side forms a line. Okay, 2 and 4 are supplementary. 6 and 8 are supplementary. All right, so we gotta get 4 and 8. Oh, goodness. What do we know? Well, we know 2 is the same as 6. 2 is the same as 6. If I put a 6 up here, I got angle 6 plus angle 4 equals 180. Oh, do I want to do that? Angle 6 plus angle 4 is 180 by substitution, of course. If I were to take this thing and if I were to take this thing here, and what if I were to minus, we're trying to get 4 and 8. What if I were to minus angle 6 from both sides? I would get angle 4 equals 180 minus angle 6. And we're trying to get 4 and 8 to be the same. If I were to take this, 4 and 8, trying to get 4 and 8. Angle 8, if I take this line here, angle 8 equals 180 minus angle 6. I know what I want to use. They're supplementary to the same angle, but we didn't have that theorem yet. I wonder if that's a misprint of my notes or what. 180 into angle 4. Then I'm going to get angle 2 equals something. Okay, let's do a redo here. Let's get rid of this. Delete. All right. If I were to take that top equation, and if I get angle 4 equals 180 minus angle 2, if I take the second equation, angle 8 equals 180 minus angle 6, angle 4 is 180. Angle 8. Angle 2 and 6 are the same. 2 and 6 are the same. Oh, I think I got it here now. Okay, scissors. Let's get rid of this. Edit, delete. All right. So angle 6, I'm going to do substitution. Angle 6 plus angle 4 equals 180. That's substitution. So I just plugged in where my arrow is here. I just plugged that into there. Angle 6 and angle 4 make 180. I'm going to take this bottom equation here, and I'm going to move angle 6 over to this side. So I'm going to have angle 8 equals 180. No, I'm not. I'm going to move angle 8 over to that side. Back. Moving angle 8 over to here. Scissors. Get rid of that. Okay, so I have angle 6 equals 180 minus angle 8. Okay, that is the, what did we do? Subtraction property. Subtraction property, number 5. Then I want to sub this into here. So I'm going to have 180 minus angle 8 plus angle 4 equals 180. That's substitution. Substitution. And then I'm going to move these two things over to the other side by subtracting the 180 and adding the angle 8. Subtracting the 180, adding the angle 8. Yay, it works. And then when I do the subtraction, this cancels. I get angle 4 is congruent to the 180s cancel out. I get angle 8. So that, voila, by a little, let's just call it addition property. Woo. I know what I want to use. I don't have the theorem yet. We haven't been given angles congruent to angle supplementary to congruent angles or congruent to each other. So we haven't had that one yet, but it's coming. So there's that. Sorry about the stalling there through that proof, but we made it. Make sure you let me know if you have any questions, and I'll see you all soon. Best of luck.